Assalamualaikum and greetings. My name is Lukman Hakim bin Zahadi, and this is the video assignment for differential equation in engineering. This is our group members. First, we have Muhammad Hikmah Hakim bin Muhammad Ani, alias Muhammad Anif. Second, Ahmad Mustaqim bin Zainuddin. Thirdly, Lukman Hakim bin Zahadi. Real-world engineering system, cooling of an object. Newton's law of cooling describes how the temperature of an object changes when it is placed in a surrounding environment with a different temperature. This principle is widely used in engineering systems such as cooling of electronic devices, for example, computer, engines, food storage, and HVAC, which is heating, ventilation, and air conditioning systems. Next, I will pass it to Ahmad Mustaqim. Thank you.
So my name is Ahmad Mustaqim Mazinuddin. My metric number is A24KT0027. So for my part is I need to explain the connection to the differential equation. That is how the equation relate to the application of the real life words. So for the modeling, the temperature T of the object is modeled by the first order differential or by the first order of the ordinary differential equation is ODE. That is delta T over dt equal to negative K bracket T minus Ts. So the initial T minus Ts, where the Ts is the surrounding temperature, for example, 10 degrees Celsius for example, and K is the cooling constant determined by the experimentally. Okay, so for the type of ODE, this is the separable linear ODE, which can be solved analytically. The solution is T equal to Ts plus bracket T naught minus Ts bracket power of negative kT, where T naught is the initial temperature, that is 90 degrees Celsius. Application to the example: by solving the ODE with the initial conditions, engineers can predict the object's temperature at any time. For example, 41.75 degrees Celsius after 20 minutes.
Right. My name is Muhammad Iqbal Hakim, and right now I will discuss about the problem example. So the question given, according to Newton's law of cooling, the rate of change of temperature T satisfies the equation given. The rate of temperature over rate of time equals to negative K T minus Ts, where Ts is the ambient temperature, K is a constant, and T is time in minutes. When the object is placed in a room with temperature 10 degrees Celsius, it was found that the temperature of the object drops from 90 degree to 30 degree Celsius in 30 minutes. Then determine the temperature of an object after 20 minutes. So now let's see the solution. So the first step, we extract all the information given from the question. So first we got room temperature, which is 10 degrees Celsius. It can be Ts. Then we got when T equals to 0, T0 equals to 90 degrees Celsius. Then when T30 equals to 30, T30 equals to 30 degrees Celsius. So the question actually asks us what is the temperature after 20 minutes. Then right now we have to find TT. So we can use the equation given. The rate of temperature over rate of time equals to negative K T minus Ts. Then we just put Ts into the equation. We got like that, T minus 10 into the equation. Then what we have to do to find the T? So next step, we have to integrate both sides because there is differentiate of rate of temperature over rate of time. Then we integrate. So on the left, we can see ln, and the right side, we can see the constant C. So we move ln to the right and become exponent. So right now, the equation becomes T minus 10 equals to exponent to the power of negative KT plus C, which is a constant. Right now, we can see e to the power of C can be a new constant. So we choose any alphabet, we choose A. And now, T minus 10 equals to A exponent to the power of negative kt. And now the new equation we got t minus, I'm sorry, the equation new is t equals to a exponent to the power of negative kt plus 10. So right now we can use a new way to find another constant also. Right now we can see there is a in k. So we can use the information given, another information given, t naught and t30. So when we put t0 equals to 90, we can put 0 in the equation and it will become a equals to 80. So that will be the first new equation. And other equation, we can put 30. So it become e to the power negative 30k equals to 1 over 4. So right now we can compare both equation to get k. So the actual k we get k equals to 0.0462. So the new equation for 20 minutes we can get is tt equals to 80 exponent to the power of negative 0.0462t plus 10. So right now we can find temperature after 20 minutes by just put 20 into the new equation, and then we can get 41.75 degrees Celsius. So that's all for the problem solution.
Hi, it's me again, Lukman Hakim. Now it's time for the conclusion. Newton's law of cooling is a foundational application of differential equations in engineering. By modeling temperature change, engineers can design safer, more efficient systems and predict system behavior under varying conditions. The example from the PDF highlights how theoretical ODEs solve practical problems, aligning perfectly with the assignment's goal of connecting classroom learning to real-world engineering. That's all from us. Thank you.